Hey y'all, CB here at NBS Welding, and we're at another Walmart. I've been called to take a look at a little issue here they've got with a handrail, and right away I see this one's definitely been hit, probably with a forklift, and it's broke. But that's not the only problem that we got, and that's not the main complaint that they had. This right here was the main issue. And what's going on here is something pretty common with handrails. These have been core drilled and set in probably hydraulic cement. And the problem with the way a lot of people do this is they get them a little underfilled, and they don't mound up the hydraulic cement around the top of the post. What happens when you do that is you have a little hole where water's going to lay, and not only does that cause a faster deterioration of the hydraulic cement in the hole, but it rots the posts away. So it's especially a shame in this situation where this is an extremely valuable handrail. If I was to build this handrail this strong with the picket pipes this close together, that is a tremendous amount of material in welding, but it makes it a good thing to repair because this is worth fixing. No doubt about it, considering that, you know, we can fix these posts, and by fixing the posts, it would preserve the handrail. It's worth doing. I mean, you can see this, to build this handrail would take a lot of material, and it would take a lot of time. It would be nice if it was core drilled and the posts were set in hydraulic cement, and that hydraulic cement was mounded up an inch or so above the surface of the concrete, because what that does is creates like a roof effect that sheds the water away. It's a better way to do it. But that's not what was done. So we've got a repair to do here, and we got to make a plan on what we're going to do. All right, y'all. So we're back at the shop, and we're doing some prep work. I've placed an order and received it from the supplier, and I want to show you some of these plates that I've had prepared. I talked to the customer about how they wanted to fix this, if they wanted to set those posts in hydraulic cement and clean those holes out, or if they wanted to do something where we bolted down the post to a plate like this. And they like the idea of just abandoning the cement idea completely and bolting the post down to a plate that's going to be bolted to the concrete. So that's what we're going to do. Now, I've got these that I ordered from my steel supplier, and what these are is a 1/4 inch plate with the holes. The holes and the plate were burned on a CNC machine. This sort of a hole, it doesn't need to be machined. It doesn't need to be perfect. It doesn't need to be drilled. It's nothing of exact machinist to the fraction of an inch kind of an accuracy. It just needs a decent hole, and the CNC plasma obviously does that. I want to talk about the CNC plasma thing for a minute because it's something that people mention to me quite often. People say I should buy a CNC plasma table because that's become a thing that shops are buying. There's a few shops in town that have a CNC plasma table. The steel supplier that I have used for decades has a CNC plasma table. Now, here's the difference between my steel supplier's CNC plasma table and the CNC plasma table that people who have shops locally are buying. The people who have shops locally are buying CNC plasma tables that'll hold maybe like a 5x10 sheet or a 4x8 sheet of steel. And that's all that a shop could probably afford to buy, unless you're a big time steel supplier with crews that work 24 hours and huge orders for steel to be cut. Now, my steel supplier has crews that run 24 hours. There's 3 8-hour shifts there. They never stop working. And they have a CNC plasma, and the bed of their CNC plasma is like 42 feet by 22 feet. You heard me right. 40 by 20 feet. It's huge. So their CNC plasma table will hold 4 of the 8 foot by 20 foot sheets of steel that come directly from the steel mill. And their shop is so big that literally like an 18-wheeler can drive to the steel mill and fill the truck up with 4 or however many, depends on the thickness and the weight, but an 18-wheeler can go to the steel mill and buy 8 foot by 20 foot sheets of steel and drive into the shop beside my steel supplier's CNC plasma. And they have cranes that'll literally lift, they have overhead cranes that'll lift an 8 foot by 20 foot sheet of 3/4 inch steel and lift it up and set it into that plasma machine. Why am I telling you this? Well, this is the explanation for the reason why I'm not going to buy a CNC plasma machine. When my steel supplier purchases this steel in an 8 foot by 20 foot sheet, and I make them a drawing of something that I want burnt out, and I take a picture of it in my phone and blast it to them either by text or email, and they burn it out and deliver it to me within a day or two, they're sending me the part burned out in the shape that I want it for less money than I can buy the steel in a 5 by 10 sheet. When they get the 8 by 20s, it's pennies on the dollar that they're paying for the steel. And that machine of theirs is going to be cutting steel 24 hours around the clock until it breaks down. And literally, it's such a valuable machine that if it breaks down, they have techs that jump on it and work on it until it's back working again. You, as a shop, you have to pick your battles. What are you going to do? Now, hey, if you produce products with custom cut things where that's something that's part of what you do, I don't really do that, but that would be a reason to have one of those CNC plasma bed machines. Or if maybe like you're an automotive place, 4-wheel drive place that does custom stuff, and you need some plates cut out. You need like 4 plates cut out for a truck suspension or something, on a regular basis. It might be worth it to you. In my situation, if I need to do something like that and I need a half a dozen plates or less, I'm slick enough. I've been doing this long enough. I'm slick enough with a torch. I can cut them out by hand. You're not going to find a lot of guys in an automotive shop that would be able to do that. They would make such a mess of it. You'd be grinding on it for a month to get something that would work. But in my case, I'm just saying, I'm probably not going to put any more tools in this shop because I can't stand a cluttered shop. If I was to buy any more tooling, I need a bigger shop because I can't stand a cluttered shop, and this shop is basically full of tools now. So when I say I have to pick my battles, my CNC plasma work is going to be getting done by my steel supply. They have to supply me the steel anyway, whether I cut it or they cut it. And they cut it at such a reasonable rate. For me to spend thousands of dollars on a CNC plasma and take the time to program it for every part, I'm just not going to do that. So that's a note on that and something for y'all to think about if you have a shop. The next part of this is going to be, how are we going to fix the rotten posts? You could weld pipe on them. If you welded pipe on them, each pipe would have to be just the right length. That's not what I'm going to do. I'm going to show you what I'm going to do. That is 1 1/4 solid rod. Now, the reason I'm using 1¼ inch solid rod, that 1¼ inch pipe has an inside diameter of about 1 5/16, maybe 1 3/8 of an inch. I'm going to just be I'm going to be cutting the rusted part of the post off and shoving that 1¼ inch solid rod up inside the pipe. It doesn't have to be an exact length then. It is going to give me something easy to weld to then. And if it's 1¼ inch solid, it's not going to rust off again. You know, the steel that rusted away when they had 1¼ inch Schedule 40 pipe, you know, that took a long time to rust away. And it was about somewhere between 1/8 of an inch thick and 3/16 of an inch thick. If this is an 1¼ inch thick, we're not going to see a day where that's going to rust off. It would take, even if you didn't paint it, which I'm sure they will, even if you didn't paint it, it would take a long, long time for that to rust through. Next thing is the bolts, where we're going to be bolting our plates down to the concrete. I'm going to be using a Simpson strong bolt, an expansion anchor in the concrete. So let's take a look at what I'm planning on doing with that. That's what the bolts look like. Picked up a couple of brand new SDS bits, and I feel like you always want to get more of these than you need. If you don't use them, take them back or save them for the next job, depending on what the chances are of you using them. Now, one of the things, there's two things about this that I want to mention. While we're doing prep work, you see, these were delivered in a box like that with a plastic pack full of nuts and washers like this. Something I'm going to be doing as part of the prep instead of being out there on the location screwing around. I'm going to stand right here at my table and I'm going to assemble these. The nut and washer has got to be put on the bolt. Why not stand here at the table efficiently and do that instead of being out in the sun, you know, on the ground or whatever, doing that? So that's something that I'm going to do. By the time I'm on site, all of these will look like this with the nut and washer in place, and they'll be in a pouch like this, ready for me to put on and, you know, go and use. So here's the next part that I want to mention. When you drill for these, you want to drill to a certain depth. And a lot of hammer drills come with like a rod. I've never had good luck with those rods staying in place. But some of them come with a rod that you can set, that'll set your depth. But I want to show you what I've done here. I want to drill about 3/8 to a 1/2 inch more than what depth I need for the bolt on these. And I'll be using air to blow the dust away. And I have taken a piece of wood and I've made me a pattern that goes onto my bit, that when this hits the steel, then that's my depth stop. And I've got this tool pouch that is going to have all this stuff in it, so that I'll be ready. I'll have all my steel in a bucket. I'll have my bolts and my tools, whatever tools are going to go in this tool pouch, and get things prepared. The prep work is just the 6 P's, you know. Prior planning prevents piss poor performance. So I try to do things at the shop with prior planning that makes the job go better. And another thing that I'm going to be doing, I'm going to be taking the diamond wheel for concrete, which is something that I flat grind steel with sometimes. I'm going to be taking the diamond wheel for concrete, and I'm going to be cleaning one side of these steel plates, and I'm going to put a really thick coat of red oxide primer on them, and that'll be the bottom of the plate. Now, when I weld the post on the plate, it's going to burn some of the primer under there. There's nothing I can do about it. You know, if they want to ever at some point lift the handrails up off of there and repaint the bottom, they can. I seriously doubt they would. And if it was me, I probably wouldn't do that. But getting a coat of rust preventive primer really thick on the bottom before we put them on is about all you can do. And I want to do what we can. So I'm going to get going on this prep, get everything ready, and then we'll head out on site. This is a diamond wheel for actually grinding concrete that come from Harbor Freight. This is what I use often to remove mill scale from steel. It does scratch the metal a little bit. It's not something that leaves a super smooth finish, but it's a very affordable way to remove mill scale and a very aggressive way using the diamonds to get this done. Resealing the gallon paint can sometimes can be a little bit of a hassle. A lot of times your lid will be pressed in, and when the center of this lid is pressed down and it's really concave, the seal for the paint can isn't going to want to seal. You can turn this lid upside down on a surface, and you want to put something like one of these grocery bags on top of it and tap it with a rubber hammer. See how this is domed back up? So that fixed that situation. Another thing is using the grocery bag as a bit of a gasket. So I have a grocery bag in between the lid and the paint can, which is working as a gasket. And I'll show you another thing that I'll do, because you want to store this upside down. If you store your paint upside down, once you've got it to the point that it's not going to leak, if there is a little leak, the paint will seal the leak. And if the paint seals the leak and air can't get in here, you can keep this paint for years and years and it will not go bad. I'll show you how to do this. We're on site, and one of the main tools as far as cutting on this job is going to be the 8-inch Milwaukee metal cutter saw. We'll be doing a lot of cutting on this with that saw. Going to be cutting the handrails pretty much into 3 separate pieces, and that's what it's going to take to be able to handle these things. These are extremely heavy handrails. This is something that normally, big contractors would send three to 6 guys out and deal with something like this, but I'm going to outsmart it. I got a lot of jack stands, come-alongs, clamps, and, tools of mass destruction, and I know how to use them. So that's the way we're going to go about it. I'm actually tacking a bar on there just to help hold that for when it comes apart and help me put it back together. And then I'll go ahead and complete this cut with the saw. The saw kind of gets bound up every once in a while, and when it gets bound up, sometimes you can't get it out, and you gotta get you a come along or a wedge or whatever and do something. Other times when it gets bound up like it did in that top right there where I was just cutting, it has cut all the way through and just bound up there at the last moment. And
So that's kind of what happened there. And then I've got this section loose where I can lay it down. And this is the kind of thing where I run into people see me do stuff like this a lot. And they always say, oh, you need some help. And I tell you, whenever somebody tries to help me deal with something heavy like this, they almost always hurt me. I can't read their mind and watch what the hell they're doing and watch what I'm doing. It's either they do something to hurt me, or they get in the way, or they get hurt themselves. I'm just, I guess, one of those people that I'm a one-man operation. I figure out how to do things by myself. I watch what I'm doing, and I use my come-alongs, my clamps, my jacks, my jack stands, and my tools to manipulate things. And I just can't have somebody else there distracting me from what I'm doing. It didn't take me long to get out the ARCCAPTAIN MIG200, and I'm going to be running the flux core wire with that on this job, and boy, it done a great job. The welding that's got to be done on this, you got a 1/4 inch base plate that gets welded to this 1 1/4 inch solid rod. And that 1 1/4 inch solid rod is pushed up inside of a 1 1/4 inch pipe. That 1 1/4 inch pipe is about 1 3/8 inside diameter, so there's just a little bit of gap, makes a really good penetrating fillet weld there on that overhead weld. Then you got that flat weld there. And this flux gun, man, it's the ultimate way to do this. If you were doing that with a welding rod that close to the concrete and dealing with the rod angle and having to bend rods because it's so close to the ground, be a nightmare. Flux core is the king here. So we're back with the 8-inch Milwaukee metal cutter, as you see, cutting off the next section of posts. I'm going to work this next section across the level and cut it off just at the top of the ramp. There was one of those that I was able to get out of there without even cutting it at the base. But most of them, I used this oxyacetylene straight torch with a scarfing tip, and I just scarfed that post off right at the top of the concrete. And all of that's going to be getting covered up with our base plate, and we'll forget it was ever there. Next thing with this Milwaukee metal cutter is going to be cutting the handrail at the top of the ramp and separating this level section so we can get it raised up and get to work on putting the parts in it. And you can see how I'm using the ramp section of handrail with this come along to hold the level section, and using the come along to raise it up, which is allowing me to get enough space between the concrete and the handrail that I can put my solid rods up inside the pipe. You see there, I went down a little too far to go back up, but the whole thing is about getting it high enough in position that I can put my solid rods in place. And once they're inside of there, I can let it back down. I was saying how the flux core wire is especially good for this because it's easy to get it in position, especially on this overhead weld where you're only 3 inches from the concrete running an overhead. And there's another advantage with flux core being electrode negative. In positions like overhead and vertical up, running something that runs electrode negative, it really helps on out of position welds, I think, because when your electrode is the cooler side of the puddle, you just have a lot less struggle controlling heat in uphill and overhead situations. And you know, you can see here where I'm laying down. If I had welding rods that were 14 inches long, I'd have to be bending the rods and doing all kind of crazy stuff to get the angle right. Shouldn't be dragging that by the gun. Gotta hit y'all up real quick with a t-shirt ad. Boss Lady Tina's selling these t-shirts. Got NBS welding on the chest, American flag on the sleeve, great big NBS welding on the back. Send Tina an email request, nbswelding@aol.com, $25 plus the cost of shipping. Thank you. Got all those other posts on this handrail done, and then I stepped back to this first one. Used the come along where I cut this in two and cut the post off. I made a couple cuts with the saw, but I still had to take the torch and scarf it down to the level of concrete and get rid of the old post. Then I used the come along off of the first handrail to raise it up enough to get my 1.25 rod and my plate in position. And then I got to splice this handrail back together with that first section and weld up the post and plate on this one. On the ramp section, I did the same thing fixing these posts. I did it in a little different order. I did the torch first, so I used a straight-headed scarfing tip to melt those posts off right at the top of the concrete. And then once that was done, I came back with Milwaukee 8-inch metal cutter saw, and I cut those posts off just right flush with the bottom pipe rail of the handrail. Within the last couple years, I've found it to be that these cordless blowers are just, they're so useful for so many things. It's been a godsend on the job site, blowing debris out of the way and blowing things out of the back of the truck. And even at the shop, I don't sweep the floor as much as I used to. I end up blowing a lot of stuff with the blower that I used to spend time sweeping, and the blower is just a lot faster and easier way to do it, and the cordless ones are especially handy. This lower ramp section definitely was one part of this job that gave me the most trouble in a lot of ways. There was a lot of crud inside of the post, so you can see me struggling a little bit to get my round bar shoved up inside of the posts, and that was something that I'd contended with on a couple of posts on here, but I got it. Once I got a few of the legs in place, I got this handrail lined back up with the level section, and I decided I was going to make a tack just on the top. There was a lot of more alignment and lifting and hinging that I needed to do, especially to get the new post put in the bottom section of this ramp rail. But I wanted to get this tacked up here, and when I made this tack, I didn't know how critical it was going to be that it was strong, but boy, it was a lifesaver that it was a strong tack. This is where things got a little hairy, and I'll just tell you right now, my big mistake was I was using this high lift bumper jack to jack up the front of the handrail, and I should have been doing this with a jack stand. I could have put one of my pipe jack stands under the front of this handrail, and that I still would have had some issues, but not probably as bad of an issue as what I had because of this type of jack that I was using. You can see this is what happened right there. And when that happened, I mean, you know, the pickets on these are so close together, you can imagine the kind of weight that this handrail's got. And right now, that tack on the top that I made earlier is the only thing holding the top of that. So if that tack were to break, this whole thing's going to come down on the concrete below, which I don't know if I could get it back up on that ramp. I might have to call for help or go get a piece of equipment. So it was one of them things where I was sure thankful that that tack didn't break. And this nice truck driver was asking if I needed any help. I pretty much told him that it was better that he just didn't get too close to it. I was more worried about his safety than anything. But this is one of those things where I had to shove the thing up where it was. And then I had to think about my next move and see where I'd went wrong and see what I needed to do to make this situation right. And once I got to the point where the weight of it was back where it belonged, I could look and evaluate and see what I needed to do. But all along, I'm thinking, you know, it's amazing that slumped over sideways as far as it did and didn't break that tack. And it's even more amazing that I shoved it back in place and it still didn't break that tack. That tack up there on the top of that pipe, it's still holding after all of that movement. And then I'm looking at this thing and I'm trying to figure out where I went wrong. And I realized that I've got that front section too high to be lifting it with a jack of that type. You know, like I said, if I was using one of my pipe jack stands, which is like a tripod stand, those don't lean like that. And then I realized when I let the high lift jack down a little bit, and that front post bottomed out in the hole, everything was fine again, and I could reassess the situation and figure out what to do. So now we're getting this wrapped up. The rest of this is pretty much more of the same. Splicing the handrail back together where I had cut it apart to raise it up and work on the posts. There's some concrete repair at the very first post and the very last post. And you'll see here, I welded them a piece of rebar, extra rebar, onto the bottom of the plate. So that'll be another little bit of help to hold that in whenever they come and do the concrete repair. I had asked them if they wanted me to do the concrete repair, and he said that he's got a guy that can do that. They just didn't have somebody to do the welding. So as long as I did the welding, they'd be good. So the welding's all done. I did put heavy coat of red oxide primer on the bottom of these plates, but they're going to have to take care of some painting too, and that'll finish this up nice.